Tangent line to a circle theorem. Tell whether AB is tangent to C. So let's go ahead and go back up and make sure we know the tangent line to a circle theorem. Tangent line to a circle theorem. In a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint on the circle. Let's see here. That is to say, is angle CAB 90 degrees? Is it right? Is this radius 90 degrees on that? And you can kind of see it. I mean, if you look closely, it sure doesn't look like it. But the thing is that we can't go by artistry because, again, anybody who's taken a math class in a classroom knows that math teachers are some of the worst artists on the planet when it comes to drawing things. So we're going to go ahead and check if this is a right triangle. That is 5 squared plus 11 squared equal to 13 squared? Well, I don't know. Let's find out. 5 squared is 25. 11 squared is 121. And 13 squared is 169. 25 plus 121 is 146. And is 146 equal to 169? It most certainly is not. In fact, it's too little. So this is, just as the picture says, an obtuse triangle, which means that AB is not tangent to circle C. Nope. Let's try this one. So again, the question is CA perpendicular to BA? And that's a question. We don't know if it is or isn't. So we're going to check if this is a right triangle. Is 6 squared plus 8 squared equal to 10 squared? Question mark. So 6 squared is 36. 8 squared is 64. Equals with a question mark. 100 is 10 squared. And 36 plus 64 is 100. Is 100 equal to 100? It is, which means that this is a right angle. So BA is tangent to circle C. Yay! Tangent line to a circle theorem. If point B is a point of tangency, find the radius. That is, now we know that this is a right angle because we're told that it is a tangent line. So that means we're going to solve this right triangle. Let's see here. And you might be saying, wait a minute, the hypotenuse is shorter, but it actually isn't. The problem is that this distance is 9, and this distance we don't know. So actually what we're asking is this leg, r squared, plus this leg, 15 squared, equal to this whole leg, which is 9 plus r squared. So let's simplify this. R squared you can't really do much about. 15 squared is 225. And when you multiply 9 plus r times 9 plus r, nine times 9 is 81. 9 times r is 9r. R times 9 is also 9r. And r times r is r squared. Reduce that a little bit. R squared plus 225 equals 81 plus 18r plus r squared. Well, look at this. Take r squared away from both sides, and it's not a quadratic anymore. Yay! 225 equals 81 plus 18r. Subtract 81 from both sides, and you get 144. Divide both sides by 18. And hey presto, you get r equals 8. The radius of that is 8. Which you can actually check to make sure it works by setting up that right triangle again. then that would make that 8, 15, and 9 plus 8 is 17, and 15 squared plus 8 squared is 289, the square root of which is 17. So that does indeed make a right triangle, and our life is good. External tangents congruence theorem. That is, if points B and D are points of tangency, find the value of x. That is, these two segments are the same length. These two segments are the same length, which means that we can set them equal to each other. 2x squared plus 2x equals 7x plus 12. Let's go ahead, and this one we're not going to be able to get rid of the quadratic, so we're just going to go ahead and solve this for 0. We're going to take 7x away from both sides. 2x squared minus 5x equals 12. Take 12 away from both sides, which means that my quadratic equation, 2x squared minus 5x minus 12 equals 0. Do I want to solve that with factoring? I don't. You know what? Whenever there's a leading coefficient that's not 1, I almost always, unless I can see a really easy factor, use the quadratic equation, which I'm going to go ahead and do right now. So A is 2, B is negative 5, C is negative 12. Here we go. X equals opposite B, which is negative 5, so that's positive 5, plus or minus the square root of B squared. Do you mind if I do negative 5 times negative 5, which is 25? Minus 4 times A, which is 2, times C, which is negative 12, all over 2A, which is 2. Now this simplifies to 5 plus or minus the square root of 25. 4 times 2 times negative 12 is 96, but since it's subtracting a negative, that's addition all over 4. Is 25 plus 96 nice? Ooh, it sure is. 5 plus or minus the square root of 121 over 4. But the square root of 121 is just 11. So it's 5 plus or minus 11 all over 4. Now 5 plus 11 is 16. And 16 divided by 4 is 4. And 5 minus 11 is negative 6. Divided by 4 is negative 1.5. That is to say that x equals 4 or x equals negative 1.5. Now, I know what you're thinking. Don't we have to worry about sometimes one of those answers not working? And the answer is that's true. Now, we know that 4 is okay, because if you look at BA, which is 2x squared plus 2x, that's 2 times 4 squared plus 2 times 4. And 4 squared is 16, so 2 times 16 plus 2 times 4 is 8, which is 32 plus 8, which is 40, which, by the way, is also works over here. 7 times 4 plus 12 is also 40. Let's make sure, so maybe BA and DA are length 40, but will negative 1.5 work? 2 times negative 1.5 squared plus 2 times negative 1.5. So 2 times negative 1.5, we're going to square that, times 2 is 4.5 plus 2 times negative 1.5. I get 1.5. So maybe that length is 1.5. Is that true for this over here? Is 7 times negative 1.5 plus 12 also equal to 1.5? 7 times 1.5, make it a negative, is negative 10.5, add 12. That's a positive 1.5, which means all we can say is that either x is 4 and AB is congruent to AD and that the length is 40, or that x is equal to negative 1.5 and that AB is congruent to AD and that length is actually 1.5. Which one of those? We cannot say. There is not enough information. Okay, construct a tangent to a circle. So given circle C and point A, construct a line tangent to C that passes through A. Use a compass and straight edge. So guys, a compass and a straight edge are two tools you use in mathematics to perform old-fashioned, old-timey constructions. And I use them like this. To perform, use a straight edge, I take my little line tool and I do that. That's the same thing as putting your ruler down and just going ahead and marking a straight line with it. Now, using the compass is a little bit different because what a compass does is it actually, you take a center, and then I'm going to go ahead and take my circle making tool. And if that's where you put your pointy end of a compass, I want you to imagine that. And then this thing is going to create points that are equally distant. Everything on there is equally distant to that circle that I made. That is, what this just did is it shows that if I connect this to this, and this to this, perhaps, there you go, that these two are going to be equally distant because they're both radii on a circle, okay? That's how I'm going to do this for you. So we're going to need to construct a perpendicular bisector of segment CA. So you're going to take your compass and put it on A, and you're going to, oops, that's not a compass. You're going to put your compass on A here, and you're going to make sure it goes a little bit past there. Now, here's the thing. You're going to keep your compass open to the same width. And I'm going to do that by making sure that my width is 1.32 is what I just did there. You would just do this by taking your compass off now and then keeping it the same amount open. I'm going to make sure mine's 1.32 inches. There we go. And then you're going to take your straight edge and you're going to connect these 2 points like that. Now you've just created a perpendicular bisector to CA. And you might be wondering how that helps us find a tangent point. And here's how. So I'm going to make a little mark here for the center of that. Because now what you're going to do is you're going to take your compass and put it on this point that you just created, the midpoint of CA. And you're going to make a circle that is equally distant from the radius to the midpoint and to the midpoint to that A, because every point on this circle is equally distant from this point, which means that if I connect A and the place where that circle meets the line, meets the other circle right there, I've created a tangent. I could have also just as easily done this one over here where the circles intersect. Let's make those real tangents, shall we? Real tangent lines. So there you have it, a tangent line that goes through A and touches C. Okay? And that's all over here. You find the midpoint by constructing the midpoint of C and A. You draw the circle around that midpoint, and then you construct the tangent line by drawing a line from that point that we were interested in to the point where that circle intersects. There's your instructions, guys. Or you could follow along there with what I did. I hope that made sense to you. There's some lines and segments that intersect circles. I hope you learned a whole bunch. Remember, if you have any questions, send a message to your instructor. This is Mr. P signing off, and I hope you have a wonderful rest of your day.